So in this example, you're given two rational expressions, x minus 1 over x squared minus x minus 6, and 4x plus 8 over x minus 2. And the task is to multiply these rational expressions together, and then to simplify our answer as much as possible, which kind of goes without saying. So what's our strategy going to be? If we zoom back and look at this problem from a 40,000-foot view, what we're really doing is just multiplying fractions. And just like multiplying with fractions, we know what to do with the numerator and the denominator on a broad scale. What do you do to multiply two fractions? You multiply straight across their numerator and straight across their denominators, and that's all. Right? That's all we need to do. That's what the strategy boils down to. So let's think about what that looks like with fractions, with rational numbers for a moment. Let's say I want to multiply 25 42nds times 28 75ths. How do I do it? Well, the first thing I'll do is multiply straight across. Right? In other words, multiply the numerators by one another, multiply the denominators by one another. That's the key step. By the way, this is also a place where students all too often are like, ooh, cross multiplying. I remember how to do this, but stop yourself. That is not how you multiply fractions. Fractions multiply straight across, not crosswise. So multiply the numerators by one another, multiply the denominators by one another. In this example, that means I'm going to end up with a new numerator that's 25 times 28, and a new denominator that's 42 times 75. Whatever those numbers are, I'm not even going to simplify them yet. Because instead of simplifying those products, what we're going to do instead is ask, okay, now that we've done the multiplication step, all we need to do is simplify this quotient. And we now know how to simplify a rational expression or fraction based on the last example we did. And that starts by factoring everything in sight. Factor the numerator, factor the denominator completely. In the case of rational numbers, we're going to do that down into the primes. So 25 is 5 times 5. 28 is 2 times 2 times 7. 42 is 2 times 3 times 7. 75 is 3 times 5 times 5. So we've broken apart everything that we can see into its constituent factors as much as possible. So now we have a complete factorization. Why do we do that? Because we're looking for things to cancel, and only factors cancel. Now that we know what the factors are, we can just identify the ones that are common on the top and the bottom and get rid of them. Just cross them out. So where are my common factors? I've got a pair of 2's, upstairs, downstairs. I can get rid of those. I've also got a 5 that I can cross out from the top and the bottom. I've got actually a second 5 I can cross out from the top and the bottom. I also have a 7 I can cross out from the top and the bottom. And then it looks like I'm done, right? On the top, I'm left now with just a 2, and on the bottom, I have a pair of 3's, so there's nothing in common. So that means we've canceled everything that we can cancel. So what do we do to finish? We just have to simplify back out, re-multiply the numerator and the denominator to get the simplest possible view of what this answer is. So we'll multiply the denominator 3 times 3 and get 9. So when I multiply these two fractions by one another, the product turns out to be 2/9. How did we do it? We multiplied across the numerators and across the denominators. Then we factored everything in sight so we knew what we could cancel. Then we canceled and re-multiplied out what didn't cancel to get our answer. Let's do that with this pair of rational expressions. So the first step was to multiply straight across, which let's just do that. I like to think of it as just taking these two fractions which used to look like they were distinct from one another and just kind of extending that fraction bar across to make it look like a single fraction, right? That's all we really did here. So now we've done the multiply step. Now we have a single rational expression instead of a pair of rational expressions. And now we just have to simplify that single rational expression. How do we do it? Well, we do it by factoring everything in sight. The x minus 1 upstairs and the x minus 2 downstairs are prime factors, right? We can't factor those expressions anymore. But upstairs, we have a 4x plus 8 that we can factor because those two terms, 4x and 8, have a non-trivial greatest common factor, namely 4. So if I factor that 4 out of that expression, I'll be left with a cofactor of x plus 2. So 4x plus 8 we've now factored as 4 times the quantity x plus 2. Downstairs, we have x squared minus x minus 6 to contend with. How do we factor it? Well, we've got to use the quadratic factoring technique, right? The sum and product technique. We're looking for a pair of numbers which multiply together to give us -6 and which add together to give us -1. Well, a little bit of guessing and checking or listing or whatever you like for this will convince you that x plus 2 and x minus 3 are a pair of factors that multiply together to give us the cross terms 2x and negative 3x, whose sum, negative x, is the term that we started with. So we can factor that trinomial as x plus 2 times x minus 3. Terrific. We're now done with the factoring. We factored everything in sight, and we know what all of the individual prime factors are. So any that the numerator and denominator have in common can now be crossed out, which is the greatest news in the world. And there's only one factor that the numerator and the denominator have in common. I just sort of rewrote them, reordered them. Don't have to do this, but I decided to do it just to get the two factors that are common close enough to one another that I can just draw a single line between them and cross them out. X plus 2 over x plus 2. Go away. But that's the only factor on the top that's common to the factors on the bottom. Everything else doesn't have a match. The x minus 1 upstairs doesn't match anything downstairs. None of the two factors downstairs match anything upstairs. That 4 is out on its own. So this is the only cancellation that we can and should do in this problem. So now that the canceling is done, we have to finish the simplifying. We now have a factored version of the simplest form of this product. So we'll just remultiply back out to get our finished answer. 4 times the quantity x minus 1, that's 4x minus 4. And then downstairs, x minus 3 times x minus 2, we have to multiply out using the FOIL technique. X minus 3 times x minus 2 is x squared minus 3x minus 2x plus 6, which when we add those cross terms, the like terms in the middle, give us negative 5x. So we'll end up with x squared minus 5x plus 6. And that then is our final answer. So how do you multiply two rational expressions by one another? The first step is to just do the multiplying. Multiply straight across the numerators and straight across the denominators. Don't worry about factoring or canceling or any of that stuff yet. Just multiply. Just take those two fractions and make them 1. Then worry about factoring and canceling. So then we factored everything in sight. 4x plus 8 turned into 4 times the quantity x plus 2. X squared minus x minus 6 turned into x plus 2 times x minus 3. Once everything is completely factored, we saw that there was one factor in this example that was common to the top and the bottom, x plus 2. So we got rid of it. It canceled away and left us with an expression which was now in simplest form, which we just simplified by multiplying everything back out.